Now we're going to take all that knowledge of DHCP and apply it to DHCP snooping. Actually, the next couple of videos we're going to look at security features that help us with attacks from very unlikely and even usually friendly sources. And that certainly includes DHCP. Innocent, commonplace, popular, helpful, whatever you want to call it. But DHCP can be used against our network, and the trouble can start as early as the host sending out that very first discovery packet. Because we know what happens then. The host is going to listen for replies in the form of a DHCP offer, and we know the host isn't particularly discriminating about the offer it accepts. Actually, the host is going to take the very first offer it gets. Now, part of that offer is the address that the host should use as its default gateway. It's no problem in this first illustration because we only have one DHCP server. The host will get the offer and set its default gateway accordingly. But what if a DHCP server not under our administrative control, a DHCP rogue server, somehow joins our network? Well, what happens here is that the host, again, is going to use the info in the first offer that it gets. And if the host uses the offer from the rogue server, and the rogue server is saying, hey, set your default gateway to 100.111, well, that is the IP of the rogue DHCP server. So then the accepted offer could also set the host DNS server address to 100.111, and that just opens the door. You know, this is just the little key going in the door. That's not causing the damage. It's once the door is open and all of a sudden hosts are sending their data to a rogue server, that's what opens the networks up to all kinds of nasty attacks. Well, DHCP snooping allows our switch to serve really as a firewall between hosts and untrusted DHCP servers. Basically, what's going to happen here is the switch is going to snoop in or listen in on DHCP conversations between these devices and make decisions on which conversations are between trusted devices and which ones are not. And this is how that's going to happen. DHCP snooping classifies switch interfaces as either trusted or untrusted. Now, DHCP messages that come in on trusted interfaces, hey, you know, pass, friend. They're going to go right through the switch, no problem at all. DHCP messages received on untrusted interfaces will be dropped by the switch, and the interface goes into the now familiar error disabled state. And you're now asking yourself / hoping, I hope there's some way that the switch can automatically detect valid DHCP servers. Sorry, there isn't. You and I, the network admins, have to do a little work there. We've got to configure trusted ports manually and explicitly. By default, this switch considers all ports untrusted because what happens is we're going to enable DHCP snooping globally in just a moment on one of our switches. Then we have to go to the interfaces that we want to trust and explicitly trust them. If it is not explicitly trusted, it is implicitly untrusted. And since all ports are considered untrusted by default, we better remember to trust some ports. Otherwise, we're going to have no dynamic IP addressing and a whole load of error-disabled ports. So let's go ahead and just work with a little basic DHCP snooping config here. You know, another attack angle that an intruder could take here is getting a rogue host onto the network, you know, and making unsolicited DHCP requests and just tying up resources. But the rogue server is a little more likely. Also, two other reasons that you will enable DHCP snooping is to make the next two features we talk about possible. Both dynamic ARP inspection and IP source guard are dependent on DHCP snooping being enabled first. So first things first, I guess we better enable it, and here's how we do that with the IP DHCP snooping command. That's it. We have some options there, but it's a legal command by itself, and that is the command that actually activates or enables the feature. Assuming that we have, one more thing here. Sorry, getting one step ahead. We want to use the VLAN option here because we need to say here are the VLANs that snooping is enabled for. And I did a write erase before this particular lab, so everything's in default. VLAN, what by default? 1, right? So let's see if we can snoop in on VLAN 1. Sure looks that way. Didn't get any warning that says you can't do that, and you actually can. So we're snooping on VLAN 1, and we're going to trust a port off, our server off port 0/1. And we've got an information option there, a limit, VLAN option, and much more importantly, trust. Trust has no options, my friend. You either trust a port or you do not. And that's really it. That's really it. Those are the concepts for DHCP snooping, a couple of important commands here. I want to tell you about one option here, option 82 in particular. And actually, let's go back to the board. I've got some illustrations here for you on that. Occasionally, we need to extend what we call the trust boundary of a security feature. And that is, we change the defaults of it a little bit and send our trust out a little further, if you will, without actually disabling the feature. And when used with DHCP snooping, the rather sinister sounding option 82, that's what you're doing. You're extending DHCP snooping's trust boundary. And this is what happens. When DHCP packets with option 82 set come in on untrusted ports that have this option enabled, the IP DHCP snooping information option, that is option 82 on the switch. When the packets come in with that set, option 82, and they come in on an untrusted port that does have this option set, those packets are not dropped. Instead, what happens is the switch injects its own DHCP relay info into the option 82 field, which includes its MAC address, and the packet is then forwarded normally. It's going to go to a DHCP server. Now, to enable that option, what you do, and it's a global configuration, is IP DHCP snooping information option. Whew. That's a long-winded command, but let's go over that one more time. And again, it is a global command. It's IP DHCP, that's the hardest part saying it, snooping, then information, and then option, and we're going to leave allow untrusted and format alone. And that's it. That's the command for it. Now, by default, the switch is going to validate the message upon its return to see if its own option 82 info is in the reply. So basically, right here, the switch is saying, okay, I'm going to pop my own information in there, and any message I get back in reply to this one better have, my MAC address, my option 82 information. And if it does, then the info is removed and the packet is forwarded normally. If not, the packet is going to be dropped. This validity check is enabled by default. If you want to turn it off for some reason, you can use the no IP DHCP relay information check command. And yeah, that is a mouthful, but again, that's another global command, no IP DHCP relay information. Let's see, that's where we're going to do, I've already looked at that. Let's do a show IP DHCP snooping. And this will give you all kinds of great information about where it's from top to bottom, where it's enabled, whether it's enabled, the VLANs that it's configured and operational on. We didn't do smart logs, so we're going to leave that alone. Insertion of option 82 is enabled, and you can see here's the circuit ID and remote ID information. Option 82 on untrusted port not allowed. And then it's going to give you your interface information down here. Here's the one interface that we're running it on. It is trusted. Allow option, yes, because we put the option command in there. And the rate limit PPS there is unlimited. So let's see. I think we've got a little information for you there. I wanted to show that because the rate limit for the untrusted port is unlimited. And it says PPS packets per second, but it really doesn't tell you, rate limit of what exactly is going on there. Well, that refers to the number of DHCP packets the interface can accept in 1 second. Use IP DHCP snooping limit rate to set a limit for that particular value. And you'll notice on this particular device, I got this config on in mine as well, iOS help doesn't mention the measuring unit. It just says IP DHCP snooping limit rate, then whatever the rate is, and then that's it. So it is a good idea to know that it's packets per second is what you're setting the snooping limit rate to. That concludes our look at DHCP snooping. We saw its operation, we saw how to configure it, a little bit of fine-tuning with option 82, and as I mentioned, this is a great feature in and of itself, but you also have to have it running for the next two features we're going to look at, which are dynamic ARP inspection and IP source guard. I'll see you on the next vid, and we will talk about DAI.